All right, so we've gone over sort of the logic of refreshing and then displaying characters on these 14 segment displays here. And I've previously shown this wiring diagram for how I've got it set up on my breadboard here. And you can see these are the pins of the actual package here. This is the overall width of the package, right? You can see here. I forget the exact number of pins, in width or breadboard rows, I suppose. But anyway, what we want is all of our anodes to be up at the top here and all of our cathodes to be down at the bottom. And the reason is, well, we've got the EEPROM here. We've got some IO pins up here and some IO pins down here. All the address pins are up here. And we've kind of got the sort of like inputs, right, of our display coming down from above here. And then they go through this decoder here for at least the cathodes, and then out here they connect here, and then we're just going to daisy chain it along for the other displays, right? We've got other 14 segment displays that we're going to plug in along here. So there's going to be two more here. So underneath is where I've got these different wires. And so if we look under here, you'll see we've got these different wires hooked up like this. I've kind of used this like gutter in here. The goal is to kind of try to keep these wires completely invisible. Just I don't know, just for a cleanliness sort of thing. But if you look here, right, we've got this is pin one. Okay, this is pin two of the actual device, right? And that goes up here and connects up here. These are two anodes up here. This is one of our cathodes, and it's just connected down here. We've got two other cathodes here. This goes down here, and this is how we get from pin 14 up here through a resistor down here, which is where we're going to hook it up to the EEPROM. And that's what you see here, right? We've got pin 14 up here, goes through a 220 ohm resistor down here, which is our pin 14 that we're going to hook up to IO 6, right, of the EEPROM. So the same thing applies sort of across the board up here. For the other ones, right, we've got pin 13 and 12, right, which are over here. 13 goes over here, 12 goes over here, and then they get carried down here. So pin 13 connects down here, right, which is where pin 7 used to be in this hole here. And then pin 12 goes here, which connects over here. And you can see that's reflected here, right? We've got pin 12 right here, and we've got pin 13 right here, right? And again, through the 220 ohm resistor. And ignore that. That doesn't exist. You see nothing. Okay. So that's what we got here. And then same thing goes here on this side for the cathodes. It's just we don't have to route them with a jumper wire, right? We just move them over here to another row through a resistor, and then we can just hook up here for our connection to the EEPROM, right? So this is kind of how we've hidden the wires underneath this, just to keep it as clean as possible. Just because these wires are a little bit, I don't know, kind of random to some extent, as at least as far as their appearance goes. And with these other jumper wires out here, I can kind of make them look. They just flow a little bit better, so they're going to look a bit cleaner. So that's the wiring of the 14 segment display, right? And that's gonna hook in like this here. So yeah, like that. That goes in right there, and that's how we're gonna control that. Now up here, we have two 555 timers. Okay, we've got the RAM here. Okay, for what's going to be this is holding the ASCII values, right, of what we're going to be displaying. And then we've got four decoders, demultiplexers. I'm not really sure the difference. I'll just call them. Well, I'll probably call them both, to be honest with you. But we have one of these demultiplexers here, which is going to be basically just cycling through three outputs to pick between these three here. I believe that's how I'm going to do it. Um, and so I'm thinking I'll control the enable pin or whatever with these. I think it's this one right here, this pin uh 7 or whatever this is. I've never been good at counting in my defense. So the point is we're going to control the output of these three with this, okay? And that's going to cycle between the three displays, okay? Now, these here are going to cycle through the digits, okay, and not just through the digits, but through the main and the auxiliary segment of each digit, right? Now, the way that we are going to be, let's see, we've got our, uh, we've got this here. So we right here, as you can see, we've got a main and an auxiliary address for this for each character, right? Now, as like I said, right, we've got a pointer that's going to point to digit 1, okay? Or wherever it's at up in memory up here, right? We have a pointer pointing to digit 1. And then we're going to have a counter that goes, to digit 2, 3, 4 and so on all the way to digit 12, right? Now, because we need to cover both the main and the auxiliary section of each character that we are displaying, if we connect the low order bit of the counter to the high order bit of the memory address or whatever, for this here, right? Because it's going to be basically holding the value here, right? Is going to be holding uh, the character that needs to be decoded here with the EEPROM, right? So if we take the low order bit of our counter and connect it to the high order bit of the let's see. Okay, I had to do a bit of fact checking myself there a little bit. So the way that we're doing this, right? We've got the main and the auxiliary address that character that we're decoding from the in the EEPROM here, right? They're offset by 128, right? And so by doing that, we make the most significant bit control whether or not we are outputting the decoded signal for the main or the auxiliary section of each character, right? So we've got the counter going into here, right, into the memory address of or to which what memory we are trying to pull from our RAM here, right? And instead of using the output 0 or whatever of the counter going to memory address pin 0, it'll go to the output 0, the least significant bit will end up controlling whether or not we are accessing uh, the main or the auxiliary, the highest order bit of our memory address here in the EEPROM, right? And then the rest of the counter bits are going to go to basically iterating through each of the 12 digits that we're displaying in the memory here, right? But then you take 7 of the pins, the lowest 7 here of the you know memory, or I'm sorry, the character that we want to display, and we connect that over here to the address pin of the EEPROM so that we're decoding that, right? Because we basically want to decode the character that is stored here, which can be anywhere from 0 to 128 in or 127 in decimal, right? It can't be above that, right? Because well, that's what we've encoded of the ASCII uh, character set or whatever, right? So we know it's going to be 127 or less. So we only need 7 of this, right? And then we take the least significant bit of the counter and we connect that to the most significant bit of our byte, for the memory that we're addressing to decode the character here. And by doing that, for each memory address here that is going to be holding the ASCII code of a character that we want to display, we are going to be there for sort of two iterations, two counts of our counter, once for main and once for aux. And so by doing that, we can use this one counter to kind of iterate through our what we want to display, and both the main and the auxiliary memory address of the EEPROM here for each character, right? So that's kind of how we're about doing that. So I'm somehow still getting confused by it, but, yeah, that's kind of the plan, and this is part of why I wanna prototype it, 'cause it's gonna be a little bit easier to keep track of once it's kind of, like, there working. It's just kind of like a weird pipe dream in my head right now. So, yeah, that's part of why we need to get this sort of here working without burning my place down, so that I kinda have, like, a reference design to then, implement in the, final product.